we go. Alrighty. Good afternoon. Hello there. How are you on Periscope? I think that says wait go. Hello, good afternoon. Good afternoon. So I hope everybody's doing good. Hope everybody's having an awesome afternoon or awesome day. My name is Jewel Martin. I am the CEO and instructor of Jumpstart with Jewel. We offer tutoring and educational services to adolescent and adult students, and we specialize in assisting students that have special needs, such as autism, dyslexia, students that may have medical issues that have kept them out of the traditional school setting. Maybe they need a little help catching up or getting some things done. Hey, Lakeisha, thank you so much for coming in and sharing my video. I appreciate it. So, I hope everybody's having a good day. So, I'm continuing on. I've been working with fractions the past couple of weeks because it is one of the most challenging subjects that my students have had to deal with. This is one of the topics that they have to deal with that I see them struggling with a bit. So, today I'm going to start to focus on today and tomorrow improper fractions and mixed numbers. We talked a little bit about this last week. Um, I went over the three types of fractions: the proper fractions, or the regular fractions, if you will, where you just have the numerator um, is less and the denominator is larger. We have the improper fraction, which you see where the numerator, it's where the numerator is equal or greater than the denominator, and then the mixed number consists of a whole number and a proper fraction. And this is one of the topics within fractions that I see some of the students struggling with the most: improper fractions and mixed numbers. Improper fraction is basically a fraction where the numerator is bigger, it's greater than the denominator. And it's improper because it really, if you think about it, it doesn't make sense. If you know anything about fractions, you know that the numerator, hello there on Facebook, how are you? You know there that the numerator is usually smaller than the denominator. The denominator is always bigger. The denominator in a fraction is the total number of parts in a shape, or if you're talking about a group, the total number of parts in a group. Well, an improper fraction is reversed basically. Improper fraction will have a fraction that looks like 6/4, 6/4, 6/4, or you even might see a fraction where the numerator and the denominator are equal. So if you see something like 10/10, we know that that is an improper fraction. We don't usually leave fractions like that. 10 out of 10 is the same as 1. So if you ever see a fraction like that where it's 12/12 or 12/12, we know we have to fix that and make it into a 1. Or another improper fraction could be, I don't know, 12/10. So we have to fix that. Mixed number, some people call them mixed fractions. Mixed number consists of a whole number. So you might see a 1 and 2/3, a whole number and a proper fraction where the numerator is smaller than the denominator. 2 and 1/4. It can be, I've seen 2-digit whole numbers before doing fractions. It just depends on what you're doing. 3, 2, this. So this example that we have here, where we have the model showing the circles divided into parts, we used this same model last week. And in this first model, it's showing you an improper fraction. I've got a circle here. This circle has 1, 2, 3, 4, 5, 6, 7, 8. So these two circles, they each have 8 parts. This first circle here, we've got the 8 parts are shaded, and then you've got the 4 parts here shaded as well. So if we wrote this model as an improper fraction, we've got 12 parts shaded out of 8. 8 is the total number of parts in each circle, but altogether we've got 12 parts shaded. This is why this is an improper fraction. It doesn't, in a certain way, it doesn't make sense. It's like, how's the numerator going to be bigger than the denominator? And that's why improper fractions have to be converted to mixed numbers. This illustration is the same as the one over here, where this is showing mixed numbers. We've got the whole fraction, the whole circle shaded in, just like we had over here. And then we have the part of the circle where you've got the 4 parts here. Half of this is shaded in. If we were to write this as a whole number, it would be 1 whole, and 4. 4 would be the numerator because these four parts are shaded over 8. 8 again is still going to be the denominator because 8 is the total number of the parts in each circle. So this is how you can have 2 fractions. This one is an improper fraction, 12 over 8. And then over here is 1/4, 1 4/8. This is the mixed number. So when you're adding fractions, I don't see it too much when subtracting, but usually if you're adding fractions, if you eventually get to multiplying fractions, when you get your answer, if your answer is in an improper form, it's an improper fraction where your numerator is larger than your denominator, you cannot leave it like that. You have to convert it to a mixed number, and we'll go over that again. And I think if I don't have time today, tomorrow we'll go over converting the mixed number to the improper fraction. They go hand in hand. They can be converted back and forth. So for instance, if I had a fraction, let's say 3/8 plus 6/8. This is quite simple. Adding these fractions together, they have the same denominator, so you don't have to convert. You don't have to find the LCD, the lowest common denominator. You just add the 2 numerators. Hello there on Facebook. How are you? I can't see the name, but thank you for tuning in. So you add the numerators together. 3 plus 6 is 9. And then you just leave the denominator the same for 8. Okay, so we have 9/8. If you think about that as a picture, once again, it's like, it doesn't really make sense. How is the denominator smaller than the numerator? You have to convert this to a mixed number. So all you do, you're going to do some division. And this is why I tell students, my adolescent students, as well as my adult students. I have some adult students that need assistance with math, whether they're helping their kids with math, whether they're going back to school and they have to take a GED test, they have to take an ASVAB test, if they're going into the military, anything like that. We go over fractions because you're going to see fractions on those types of exams. You have to know your multiplication facts as well as knowing division. So we write it as a division problem. 8, which is your denominator, becomes your divisor. 9 is going to be your dividend. It goes right here, and then we have to do the simple division. How many times can 8 go into 9? If you know your multiplication facts, you know it can only happen once, right? You put your 1 up here, that's the division, then we have to multiply. 1 times 8 is 8, and then we subtract. 9 minus 8 leaves 1. And so instead of it being like a remainder of 1, where you would do a regular division problem, this becomes your new mixed number. 1, the remainder, becomes your numerator. And then 8 is still your denominator. So your answer, you took 9/8 and you transformed it into 1 1/8. And I apologize if somebody's putting a note in Facebook. For some reason I can't see it, so if someone's making a note in Facebook, I'm sorry if I'm not responding. For whatever reason, it won't let me see it. Okay, so the answer for this one is going to be 1 1/8. We converted our fraction from an improper fraction, 9/8, to a mixed number, 1 and 1/8. We'll try another one. Let me see if it'll let me insert a blank page. Okay, so let's try another one. Get my pencil back. Okay, I've got 9. I'm sorry if it's a little sloppy. I'm using my mouse. 9/12 plus, no, that's not. I was trying to make an 8. 12. So same thing, the denominator is the same. We don't have to convert the denominator. We're just going to add the numerators. So 9 plus 8 is 17. The denominator is the same. It's 12. Again, this is an improper fraction. The denominator is smaller than the numerator. You cannot leave it like that. It's improper. We've got to convert it to a mixed number. So here we go again. We're going to do division. So we take the 12. The 12 becomes our divisor. Put our little division sign up. That looks real sloppy. Sorry. Me and this mouse. And then our 17 becomes the dividend. So same thing. We're going to divide. How many times can 12 go into 17? If you have a group of 12, how many groups of 12 can you make with 17? If you've got 17 pencils, how many groups of 12 can you have with 17 pencils? You're only going to have one group, right? So you put the 1 up here, and then we multiply. 1 times 12 is 12. We subtract. 17 minus 12 leaves us with 5. And instead of it being a 1 with a remainder of 5, because we're doing fractions, we're going to make our answer a fraction. So our remainder, 5, becomes the new numerator. And then our denominator is 12. And so our answer here is 1 and 5/12. There are going to be times when, and we might go over that tomorrow, where you have to simplify a mixed fraction, a mixed number per se. If you have if it's 1 and 3/6 or something like that, there are going to be times you're going to have to reduce the fraction. And we might get into that maybe tomorrow or Wednesday. I'll do one more. Let's see, 8 over 11 plus 5 over 11. So same thing for this instance. Denominators are the same. We're adding the numerator. 8 plus 5 is 13. And then 11 is still our denominator. And of course, that's an improper fraction again. The denominator is smaller than the numerator. We can't leave it like that. We have to convert it to a mixed number. It becomes division. 11 becomes our divisor. 13 becomes our dividend. So here we go again. 11. How many groups of 11 can we make if we have 13 items? If we've got 13 crayons, how many groups of 11 crayons can we have? Only one. 11 can only go into 13 one time. Then we do our multiplication. 1 times 11 is 11. Then we subtract. 13 minus 11 is 2. So again, instead of this being 1 with a remainder of 2, we turn this into a fraction. Our whole number is our 1 here. The 2 is the numerator. And the denominator is 11. So we've got 1 and 2 over 11, or 1, 2, 11s, however you want to say it. And that is how you convert the improper fractions to the mixed number. You may have an exercise where it may just show you. It may not even be an addition problem for fractions. It may just say, hey, convert these improper fractions to mixed numbers. So you may see something where it's like 20, because sometimes you'll see that too. It might be like 20 over 9. And they'll just say convert it to a mixed number. Okay, Same thing. 9 divided into 20. You've got 20, I don't know, cupcakes. How many groups of 9 can you make out of 20? 20 cupcakes. So you know your multiplication facts. You know, okay, 9 can go into 20 twice. I can make 2 groups of 9, right? Because 9 times 2 is 18. So 9 times 2 is 18. 18 here. 20, take away 18. If you're good with your math, you can just do 2. If you have to regroup to do it, that's fine. You would just regroup, or what we used to call carrying over. We used to call borrowing for subtraction and carrying over for addition. But you may have to borrow or regroup. If that helps you, 2 becomes the 1. You give that 1 to the 0. Now you've got 10. Take away 8. That leaves 2. And again, it's not going to be a remainder. This is a fraction now. So it's 2. The numerator becomes 2. And the denominator is now 9. And there you have it. So I thank you all for watching. Again, if you're saying something in the comments for whatever reason on Facebook, I can't see it. So I apologize if you're asking me a question. I think once I end it, I don't know why it does that sometimes. Once I end it, if you put something in the notes, then I can go back and respond to it. But for some reason, I can't see it now. But that's the mini lesson for today. So just make sure that you're following. I think I just got a friend request from somebody, so I'll see what's going on and accept it. But I'm here Monday through Friday at 3:30 Eastern Standard Time doing math mini lessons with Mrs. Jewel. So everyone have an awesome, awesome day, and I will see you tomorrow. Okay? Take care and have a great day. Bye-bye.